Hey everyone, it's Chris here. So today I'm going to be showing you how to create your own finite element analysis application in under 10 minutes using the GenFEAx structural analysis library for .NET 10 and the C# language along with some AI assisted code. So you don't need to know much about coding. All you need to know is what to do with a code block, how to insert it into a solution and how to run it. So to do that, we're going to go to the BIMWERXFEA.com website. From there, you'll see, if you scroll down from the main page, under latest news, we've got a button there, GenFEAx GPT. So when you click on that, it's going to open up a new window and navigate to OpenAI's webpage for ChatGPT. And we've built a custom GPT called GenFEAx engine. And this has been trained and fine-tuned on the .NET structural analysis engine called GenFEAx. So in here you'll find a couple of example prompts, and we'll just choose this fourth one. So I'm going to go ahead and click on that. You'll notice we're using the 5.2 thinking model. You can of course change that if you've got access to the Pro model or other models that you prefer to use, but the thinking model is the recommended one. Now in this one, in this example, it's going to build a .NET 10.0 C# function to calculate the deflection at the mid of a rectangular concrete beam, 6 meters long, 200 by 350 rectangular section with pin supports and a 4 kilonewton per meter UDL. And we're telling it to output the results in a message box, and we wanted to use the MKL solver in the back end. So those are the instructions. Of course, you can expand and elaborate on this and be more specific, but that's what we're going to do for this exercise. This is going to take a minute or two to think, so while that's happening, I'm going to go ahead and fire up Visual Studio. By the way, if you're not familiar with Visual Studio yet, it is free. It's from Microsoft. You can download it and install it. It's quite easy and simple to do. I won't cover that in this tutorial, but there's a lot of resources online to do that. So if you don't have it installed already, go ahead and do that. Visual Studio, not Visual Studio Code. Once you've got it installed, we're going to click on Create New Project, and we'll use the C# Windows Forms app. So if this template doesn't display already on your new projects dialog, then all you need to do is to access the C# language here from languages. It's going to be Windows based and it's going to be a desktop app, and from there you'll see the Windows Forms app. The one just below it that says .NET Framework, that's for the older 4.8 and earlier frameworks of .NET. Now we've built a bridge for GenFEAx to be able to hook into the analysis libraries, but we won't cover that here. We're just going to stick with the native .NET 10.0, which is this option here. I will click Next. Finally, we need to give this a name. So I'm going to call this one GenFEAx AI sample. All right, and that's it. We click on Next. Finally, it's going to ask us for the .NET framework. We'll choose the 10.0 long-term support. That's important. So we'll click on Create. Now, while that is setting up and initializing, I just want to show you what the libraries look like that we ship with the download that'll be available soon. It's not yet today, as of the 26th of January. It's not available yet, but it will be in the next day or two. So before the end of January 2026, you can download and install these libraries and tools. And what it'll do with the installer is it'll install to your app data roaming folder under BIMWERX. This is also where our other desktop apps live, but GenFEAx, the engine, the analysis engine, will sit under GenFEAx. And there's two subfolders. License Manager, which I'm going to cover in a subsequent video on how to deal with the License Manager for the free license that we offer, the student license that we offer, for single user licenses, as well as developer and deployment licenses. So all of that in a separate video that we'll release shortly. For now, we want to focus on the libraries that ship with GenFEA analysis engine. So it's under libs, and you'll see there's two folders here, .NET 10.0 and .NET 4.8. Today we're looking at the 10.0, and in here you'll see the GenFEAx.dll. That's the main library that we want to reference to. The license library you don't have to reference to, that'll automatically be accompanied by the GenFEAx.dll. And there's a runtimes folder that contain the optional and additional MKL libraries for those solvers, which I'll demonstrate to you how that works in a minute. So we can see now that our form has initialized. So what I'm going to do here is I'm going to drag a button onto the form, and we're going to give it a name. So we'll just call this one here BTN LinStat. It's going to be a linear static analysis of a beam, so we'll just call this linear static test. There we go. All right, I'm going to double click on that, and that's going to take me straight into the backend code of the form and also that button. Now, before we continue, let's quickly add those dependencies. So what I'll do from the Solution Explorer, where it says dependencies, I'm going to right click and choose add a project reference. Click on the browse button and we will browse to that DLL, and again you'll see that takes me to wherever, but I need to navigate then to your app data. So a quick way to do this is you type %app data %. From there we can go straight into BIMWERX, GenFEAx, libs, .NET 10.0, and we select the GenFEAx.dll. All right. Now that we've got that referenced, we can actually start coding. So let's go ahead and have a look at what the AI has done. So we can see it's already generated some code here for us. What we'll do is we'll take all of these imports here above the namespace, because that's what we want to bring in, paste it in there, and then we'll go into our form code where we can start generating or placing this code here. So we can see it's created its own namespace. We've already got one here at the top, so we've got a namespace here. So we don't want to override all of that. That'll break things. What we want to do is we just want to extract the code block here that we can then call afterwards once we've plugged it in. So I'll copy that, paste it in here, make sure we've got no errors. I see we do have some errors here. So if we go here, we can look at that and we can say, all right, take that error. That's actually a good example. There shouldn't be errors, but there is. And I'm going to say IDE errors, and I'll just paste it in there. That's actually a good thing that it happens, because that shows you how we deal with IDE errors and send that back to the AI and get it to fix that up for us. So while that's fixing it up, let's continue. We'll know that once this is fixed up, we're going to be calling this function in there. And that's why we need to place that in our button. Now, I did talk about the MKL libraries. So I said that under the relevant libraries folders here from the install, it sits under runtime. So all you do is you copy that to the clipboard, the runtimes folder, and we'll then open up the solution here. So you'll see if I go to the, my project here and I right click and I choose open file in Explorer, we go into bin, we go into debug, we go into that folder, and we just paste it in there. Our DLLs and EXEs, the application files, will be built and sitting direct here under .NET 10 Windows, and in the same folder we want the runtimes folder to exist there. So now we can see this is changed or adjusted, so we can copy that, and let's go and fix that. So we'll pop back in here and we'll just replace this with the code that it is now generated. We don't have any errors, so that's looking good. Let's hit the play button here and let's see what happens. So we'll just let that build. We can see it's now built it. Now before I click on the run button there, let's just go back here. You'll notice now in that folder, as I said, it'll place the DLLs that's referenced into it. It'll actually build the application, and then we want that runtimes folder to sit in that exact location in the root of where our application file sits. And if we click on linear test there, we can see now it runs. We get the mid-span deflection, 4.02 millimeters, and it's giving us some other outputs there of the section and material properties that we defined earlier. So really simple, really quick. This is a basic example, but you can explore with that a bit. You can expand on the prompting and you can make it more complex, and you can build fully functional structural analysis and design applications using this engine and with the assistance of AI. So give that a try. Let us know how you go, and watch this channel for future videos on how to run other types of analysis, how to use the licensing engine and other features. All right, have a good day. Cheers, bye.